You know, we spend pretty much our whole lives inside buildings, but we almost never think about what's actually holding them up over our heads. It's this invisible, super powerful framework, a skeleton really, that keeps everything from coming down. Today, we're going to pull back the curtain and see exactly how it all works.
No, really, just take a second. Look around you, above you, below you, hidden inside those walls. There's an entire structure doing all the heavy lifting. So what's it made of, and how did the builders decide what to use? Well, let's dive in and find out.
Okay, so every single building, and I mean every building, has something called a structural system. You can't see it, but it's easily the most important part. Just think of it like the building's bones. Its one and only job is to provide strength and stability against, well, pretty much everything.
So what's its job? Well, it's pretty simple, actually. It has one main goal: to fight against all the forces or loads acting on the building. That's the weight of the building itself, all the people inside, even something like the wind pushing against it. It takes all of that pressure and channels it down safely through beams and columns right into the foundation. All right, first up, let's talk about the undisputed champion of building materials, the one you see everywhere: concrete. Now, on its own, it's just a simple mix of stuff like cement and sand. But when you combine it with something else, it becomes a true super material. And this is where it gets really clever. See, plain concrete is fantastic when you squeeze it. That's called compression. But the second you try to pull it apart or bend it, it just cracks. Steel, though, is the total opposite. It's amazing at resisting being pulled. That's tension. So by putting a steel skeleton, what we call rebar, right inside the concrete, you get the absolute best of both worlds. The concrete handles all the squeezing, the steel handles all the pulling. It's a perfect partnership.
And that amazing partnership? That's exactly why you see reinforced concrete pretty much everywhere. You can pour it into molds and make any shape you want. It can last for 100 years, and it's fantastic against fire. Plus, it's relatively cheap. But of course, there's always a catch, right? For one, it's incredibly heavy. And you can't rush it. Concrete takes a long time to cure and get to its full strength, which can really slow a project down.
Okay, so we know what it's made of. But how do these materials actually become the skeleton we're talking about? Well, a lot of the time, they're used to build a framed structure, that whole network of columns and beams. And when it comes to how you make these frames, there are really two big competing ideas. Do you build it right there on site? Or do you make the pieces in a factory and just assemble it?
And this slide just lays it out perfectly. On one hand, you've got cast in situ concrete. That's where you build the molds, pour the concrete, and let it all happen right there on the construction site. It's super flexible for wild, unique designs, but like we said, it's slow. Then you have steel frames. The parts are all made in a factory, shipped to the site, and then bolted together like a giant Meccano set. This method is incredibly fast, and the steel itself is unbelievably strong.
But hey, it's not all about concrete and steel. Let's not forget about the OG building material, timber. And timber isn't just for old log cabins anymore. Thanks to some amazing modern engineering, wood is having this huge comeback as a high-tech, lightweight, and seriously strong structural material. We're talking about massive, multi-story buildings being built out of wood today.
So, what's the big deal with timber? Well, its biggest selling points are speed and sustainability. Just like steel, it's perfect for prefabrication, and it's hands down the most eco-friendly choice. The challenge, though, is you have to manage its natural weaknesses. If it's not treated properly, it's vulnerable to things like fire, rot, and insects. So you really have to know what you're doing.
And that idea of prefabrication, it leads us to a huge shift in how we think about building. Both steel and timber are perfect for it. The whole idea is to take the messy, unpredictable work that happens on a construction site and just move it into a clean, controlled factory setting. It is a total game changer for the industry.
I mean, the process itself is just so logical, it makes perfect sense. You build whole sections of the building, walls, floors, you name it, in a factory. Then you put them on a truck. And finally, a crane just lifts them into place and you connect the dots. This method cuts down construction time like crazy, creates way less waste, and you don't have to worry about a rainy day stopping all the work.
Okay, so after all of that, what's the final verdict? Which skeleton is the best one? Well, the truth is, there is no single right answer. The choice between concrete, steel, or timber all comes down to the specific project. It's this complex puzzle, right? You're balancing cost, how fast you need it done, the design, where it is. It's always about the trade-offs.
And really, this table here just lays it all out for us. If you need total freedom with the shape and top-notch fire resistance, and maybe speed isn't your biggest concern, then reinforced concrete is a fantastic choice. But if you need to build something super fast and light, steel is your go-to. You just have to add some fire protection. And if being green and lightweight are your top priorities, timber is an amazing contender. Each one has its own personality, its own list of pros and cons.
So the idea here is that from now on, when you walk into a building, an office, your house, a stadium, whatever, you'll have a much better idea of that invisible skeleton holding it all together. The next time you see a building going up, look for clues. Are they pouring concrete or are they bolting together big steel beams? What kind of skeleton do you think it has? And more importantly, why do you think they chose it?